So for this part of the lab, our goal was to explore how we represent document concepts using embedding. I'm going to explain the initial doc2vec analysis that we did. So to find the most effective configuration for the doc2vec model on our Reddit posts dataset, the main question we were asking was how does changing the vector size of embeddings affect the ability to group similar documents together? So first, we took the data that we had collected in lab 5 from the database. Then, then once we had that data, we then used doc2vec to convert each post into a numerical vector or an embedding. We did this 3 separate times to create 3 distinct models, with the primary difference being the vector size. One model with 50 dimensions, the other with 100, and then the third one with 150. So once we had these 3 sets of embeddings, we used a simple clustering algorithm to group the posts based on their vector similarity. And to determine which configuration was best, we used a two-part evaluation. The first one was a visual analysis, which generated this visualization. And the second one was qualitative results. So for the first one, the visualization, it shows us the clustering results for all 3 models. The data is a bit imbalanced for cluster 0. That's why the yellow is dominating a lot. On the left, for the model with vector size 50, the results are a bit messy. The colors, which represent different clusters, are heavily mixed, and there are no clear boundaries. The model with 100 dimensions in the middle is slightly better, but it still shows significant overlap. But finally, the model with 150 dimensions. Here we can see clear, distinct groupings of color. The clusters are far more separated, which suggests that this model is much better. It essentially did a much better job at separating our documents into unique topics. Next, the text results or the qualitative results, the text output of the clusters, which we can see in the terminal. The models with smaller vector sizes, they created very poor groups, as we can see for the first configuration, which was about 50 dimensions. Their main cluster was mixed completely, unrelated topics like kernel development and other job seeking, something like job seekers, all together showing that they didn't really understand the content. This and then the next one, the configuration 2 with dimension 100. It's a similar story over here as well. But for the third configuration, which was the one with 150 dimension, tells a much different story. Here we can see clear, distinct groups being formed, like for one for the database, the architecture. The clusters are far more separated, which suggests that this model did a much better job at separating our documents into unique topic. Conclusion, the analysis clearly shows that the doc2vec configuration with a larger vector size, that is of 150, was the most effective. It was able to capture more of the semantic details within the Reddit posts, within the subreddit that we chose, which was programming. It resulted in a more accurate and meaningful clusters, the one with the higher dimension size. Now my teammates will explain the further analysis that was done.
Hello everyone, this is Shivani from Team ADS. I have tried word-to-vec binding method. So I will explain you the method and then show how we have evaluated the cluster quality, present numerical results for 3 embedding dimensions, and then walk you through the TSNE visualization that will give you a clear idea about the results that we have tried to produce. So first we will go through the method word bins. We have trained the word2vec model on the full corpus with vector size of dimensions 50, 100, and 150. Then the window length is 5 and the minimum count is 2. Next, we have clustered the learn word vectors into k clusters using k means. For each document, we have computed a normalized histogram of document words across these k clusters. That histogram is documents vector. So intuitively, WordBeans compresses per word semantics into distribution over word topics. For each K, we have computed the silhouette scores, and you can see the silhouette scores right here. Yeah. The silhouette measures the intercluster tightness versus the intercluster separation. Higher is the better, basically. We also have produced the TSNE plot for visual inspections, coloring points by K means cluster at a chosen K. So I would also like to walk you through that. Yeah. So for dimension 50, we have the word bin silhouettes as 0.12 and the Dr. Vec silhouettes is 0.71. For dimension 100, we have 0.21 and the K chosen is 2, while the for Dr. Vec it's 0.72 and the K that it has chosen is 5. For 150, it shows 0.12 to 62 and the chosen K is 5. For Dr. Vec, for dimension 150, it shows 0.72. The chosen K is 2. Uh, in the word beans, TSNE you see is overlapping point clouds at the diffuse cluster. The histogram representation tends to group many documents toward because shared higher frequencies words and produces similar bean counts. Thank you.
Hi, my name is Day. I am part of the ADS team, and today I would like to demonstrate our lab-based solution for document embedding analysis. So basically, we will explore how different embedding methods perform on Reddit posts. So here, basically, we are using the programming subreddit and determine which approach better represents document meaningness. So our project basically analyzes 300 Reddit posts from the programming subreddit using two different embedding methods. The first one is TF-IDF and the other is word frequency. So we test each method across three dimensions, 50, 100, 150, to find the optimal configuration. The goal is to basically cluster similar documents and evaluate which embedding method creates more meaningful clusters. So the first method that we used was the TF-IDF analysis. So here TF-IDF basically weights words based on their importance in individual documents relative to the entire corpus. This means that rare but meaningful words get higher weightages, while common words get lower weightages. Talking about the results for TF-IDF, out of both of them, TF-IDF performs the best at dimension 50 with a silhouette score of 0.309. So it basically creates 10 distinct clusters, each representing different programming topics like Rust development, web frameworks, and software engineering clusters. Now moving to the second method, which is word frequency. So word frequency creates normalized frequency vectors where each dimension represents the proportion of words from a specific vocabulary bin. It's simpler, but treats all words equally regardless of the semantic importance. So the word frequency achieves its best performance at dimension 50 with a score of 0.235. It creates fewer broader clusters, typically 7 to 9 clusters, with less distinct topic separations. So looking at the cluster keyword analysis, TF-IDF clusters show specialized topics like Rust backend project, Whereas here, looking at the word bins, we only see limited classifications which includes what code just from your, which are not very ideal. Also, the performance table shows that TF-IDF consistently outperforms word frequency across all dimensions. At dimension 50, TF-IDF achieves 0.309, whereas word frequency achieves 0.3235. This is about 30% improvement, which demonstrates TF-IDF's superior semantic understanding. Also, TF-IDF creates more granular clusters, which are in this case 10 as compared to 7 to 9 for Word2Vec, enabling finer topic separations. So, talking about the advantages and disadvantages. In case of TF-IDF, we have better semantic understanding, which is effective, rare word handlings, superior document discrimination, and uh, higher reliability. However, it has higher computational complexity and memory requirements as well. In case of word frequency, simplicity, computational efficiency, easy interpretation, and robustness are the positive points for it. But it suffers from limited semantic understanding and poor discrimination between similar documents. So, based on our analysis, we can see that in the average performance by method shows that TF-IDF performs better, and TF-IDF is the clear winner for representing document meanings. It achieves higher clustering quality, creates more meaningful topic clusters, as we can see in this different cluster examples. And basically captures semantic relationship in a better way between documents. While word frequency offers computational advantage, TF-IDF superior semantic understanding makes it the preferred method for document embeddings. Thank you.